My name is Eduardo Francke, and this is Lab 2 for Physics 2212. Introduction. The purpose is to create a model of the charge tape experiment in GlowScript using various point charges to represent the tape. Some of the concepts used were Coulomb's law, Newton's second and third laws, electric fields equation, gravitational force, and vectors. Some of the main results. In these observations, you can see two pictures of the model. The one on the left side was the model when the experimental charge found in Lab 1 was used, and on the right side, it's the new value found in Lab 2, where the force due to gravity and the electrostatic force counteract each other. The U-tape's total charge as predicted by the model was 2.582 e to the negative 8 coulombs. The initial prediction from Lab 1 was 1.709 e to the negative 8 coulombs and was within one order of magnitude of the real charge. Some of the assumptions made. The tape in this experiment was treated as a set of point charges in the model, with the tape's total charge being represented as a line of concentrated point charges. This could cause some possible error, as in reality, the pieces of tape are two solid pieces of material which are evenly charged throughout, and representing them as 10-point charges can cause possible error. This was done so that we use Coulomb's law for the electrostatic force of a point charge on all 10 point charges. The tape is assumed to have the same charge distributed across the entire surface. Humidity is negligible, which would cause loss of charge of the tape over time, and we also neglect air resistance. The basic procedure. A model was made on GlowScript which modeled the tape experiment from Lab 1, except the pieces of tape were represented as two lines of 10-point charges, which were spheres in GlowScript. Coulomb's law was then used to find the net electric field at the location of each charge on the top tape due to all the charges on the bottom tape. The electric fields at each point, the overall electrostatic force on the tape, and the force of gravity were represented as arrows coming from each charge. Some of the data. Constants. The mass of the U-tape was 2 e to the negative 4 kilograms. The distance between tape A and B was 0.025 meters. The force of gravity was 1.962 e to the negative 3 newtons. The electric field force when using the experimental Lab 1 charge was 1.962 e to the negative 3 newtons. And when using the new theoretical charge, 8.596 e to the negative 4 newtons. The charge on the tape, experimental value from Lab 1 was 1.709 e to the negative 8 coulombs, and the new theoretical value 2.582 e to the negative 8 coulombs. This is some of the GlowScript that was used. On the left side, you can see that some of the constants are laid out, and a function made to calculate the electric field at a particular position due to a charged particle is established. On the right side, another function used to find a line of charges of 10 charges, meaning to represent both strips of tape, is also used. Moving on the left side, some other scale factors and vectors are initialized, and then a double for loop is created in order to find the electric field at each point on the top tape, and also find the force of the electric field on the top tape overall. On the right side, two arrows are made, one to represent the total force of the electrostatic force on the top tape, and another one to represent the force of gravity on the top tape as well. Here's two more pictures of the results of the GlowScript. Again, on the left, the Lab 1 charge is used, and on the right, the new theoretical charge is used, in which the force of gravity and the electrostatic force cancel each other out. Some of the questions. What was the magnitude of the charge on one piece of tape as calculated by your computational model? 1.716 e to the negative 8 coulombs for Lab 1 and 2.582 e to the negative 8 coulombs for the theoretical. What assumptions, approximations, or idealizations did you have to make to determine the amount of charge on the floating tape? We had to treat the long tape as though it were multiple point charges, 10 in this case, with all of the charge concentrated at the center of each charge, and we assumed that each U-tape had about the same amount of charge evenly distributed across the length. Discussion questions. What if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you got when you use your experimental data to produce a point charge model of the value you got with your line charge model. The estimated value of the charge from Lab 1 was 1.709 e to the negative 8 coulombs. This was almost half the size of the new established value of the charge using a line of charges, which was 2.582 e to the negative 8 coulombs. Why do these estimates differ? Which value is more likely to be used closer in the real value, and why? The closest one to the actual value is the new estimation, since it more accurately represents a real strip of tape, which is a solid strip of charged material, not a single point charge.